Good evening, sir. We are from Group 27, and now we will be explaining about the code for Lab 5 and demonstration. So I will be explaining about RTC. So for this part, this is how we set up the RTC according to the lecture slides. And then in here, timekeeper. This is when every time, every ticks for the RTC, second will plus 1. So the second will keep on plus 1 until when it is 60. When it is 60, minute will plus 1, which means that it already reached 1 minute. And then we set second back to 0. So when it same goes to this one, so every time when minutes, the process will keep on going until minutes reach 60, we will plus 1 for our hour. 1 hour equals to 60 minutes, and then we set minutes at 0. Then every time when hour hit 24, we will plus day plus 1, and then hour we will set to 0. So and then it keeps going until month, but month there is a bit difference. For February, we have leap years and not leap years. For leap years, there will be like 29 days. So we will be divide the years with 4. If there is no remaining, then the remaining is 0, then we will goes to here. So when the day reach 30, month will plus 1, and then we set day as 1, so it will goes back, it will repeat. And then, but if we divided by 4, it is not there are remainings, means there are 28 days. So when day hit 29, month will plus 1, and then day will be equals to 1. We will set day back to 1. So for this part, we have January, March, and May, June, July, August, and then October. For this one, there are 31 days. So in this case, when day hit 32, month plus 1, and then day set back to 1. And then for those who have 30 days, April, June, September, and November, they have 30 days. So when they hit 31, month will plus 1, and then day will be set back to 1. So now we will go to years. So 1 year has 12 months. So when month hit 13, year will plus 1, and then we set month back to 1, which means it will goes back, and then day goes to 1 as well. So and then for this one, this is what we get from online, Tomohiko Sakamoto algorithm. This is the function that enables us to know which day is Monday, which day is Tuesday, and so on until Sunday. And then this is just this is how we enable the RTC. That's all. And then for the last part, this one is we call the function that we need to use RTC, which is the timekeeper and the down function. So now I will pass to Alex.
Hello, I'm Alex, and I'll be explaining about the interface where the clock can roll the time correctly for our minute and second. This one is already taken by Vince just now, so I'm gonna explain how we can set the time and date. So basically, what we have here is our okay, our menu here. Now, for the program, it's basically simple. If alarm is enabled, right, it will go right to alarm. But if it's not, it will go to show time. So, and then if we press the center button during the show time program, the function, you go to the menu. Now the menu I created in such a way that it switches dynamically. So we have option equals to 1 initialize, and then back equals to 0. Back is needed, so we can go back from a function basically. Now we have a while loop. So if it's not 0, it'll keep showing it, and then if there is a flag saying back is 1, you skip back, you break the program and go back to the previous one. So for the menu, simple, we use a switch loop for it. So for the first case, basically we set alarm here, set time, set date, music, and back. Music is an extra function. So for set alarm, basically it's simple. Using the same menu interface, the style, we have we have two new variables we introduced inside, which is hour and minutes, a hour and a minute. This one is to indicate this is used by the alarm function. So for basically what I did was when it is on the first case here, we have two buttons we can press, left or right. This one will set the hour for the alarm. So left basically is to decrease, and then right is to increase. So when it reaches less than 0, there cannot be a negative 1 hour, so we're gonna wrap it back to 23 hours. And for right, it's the same thing. We reach 24. In this case, it becomes a 0. So 0 to 23 is 24 hours. Same thing with minutes, the same concept as just now. So basically it's like this, 59. When it reaches negative, because there's no negative minute here, so it will go back to 59. So this one is when it reaches 60, you go back to 0. Means that it has 0 to 59, 60 seconds. Now for the third, 60 minutes, sorry. And the second, it doesn't matter because the alarm will trigger at exactly 0 second of the hour and minute. So for case 3, which is this one, is set. Set, once you press it, because you have the a minute and the a hour already set, basically it's a global variable. We're gonna parse it, and we set the flag arm alarm to 1. So like I said just now in the first function here, where is it? Okay, here. Basically, if it detects arm alarm 1, and then the hour we set and the minute we set, plus the second at 0, at that time the alarm will activate. Next, we have what if we don't want to set it? We just put like for fun, and then we don't want to set anything. So I put a so-called fail-safe here. It's a back button. Basically what it does is arm alarm to 0, and then alarm hour to 0, and alarm minute to 0. Basically it becomes nothing, plus the arm alarm is 0, so it won't trigger in the program function. The next one is to set time and to set the date. Okay, for the time, it's the same thing actually for the alarm, but instead of putting it to alarm, basically what we did is we declared two new temporary variables, t hour and t minute. Again, second doesn't matter. So for the minute, when we set it, we make the hour of this is the global hour. We make it to the value of the temporary hour, and also the minute to a temporary minute. Second remains unchanged. So back the same thing, and we basically put the temporary hour back to 0 and temporary minute back to 0. Plus, it does not change the hour and minute of the global time. So basically, it's like a back. Now for set date, it's a more complicated. Again, using the same interface style for options, and pressing left or right to determine your year. Year, basically, you cannot have negative 1 year. So basically, if you try to go back to negative, you try to make it negative, you'll just go stuck at 0. Nothing will happen to it. For right, you'll just continue plussing until whatever date you want. So for month, same thing. Once it reaches 0, straight go back to 12, because there's no 0 month, only like 1 for January for us. And then if there's no 13 month also, so basically if 13, you just go, you'll just wrap back to January. For this one, we did not add a back basically, because in our main function, we initialize the temporary day, the month, and the year to the system year. So let's say if you make changes, or you did not even make changes, and then you just press set, yeah, basically it's like that. So same thing as the timekeeping just now. For the month, we need to know which one is the leap year or not. So basically we have a temporary year divided by 4. So we have to set it like year month, and date in this order, in this particular order, because the month will really affect the date, and then the year will affect the month. So same thing, if it has no remainder, means that you can only do it until 29, and then you wrap back. And then for non-leap years, you wrap back to 28. If you try to go back, there's no negative day. So for month, same thing. For the day, the temporary day, this one is for the 30 days, and then this one is for 31 days. Now write the same thing, we do the same thing, but this time it's the other way around, because we're plusing the day, the month and the day. So there's that. Now for case 4 is basically if you press center set. Now I have something in mind, which is to prevent, let's say somebody is mischievous, they try to set the month around again, like let's say you put a 30, you put a 30 in the date, and then you go back to month, and you just set it to 28, let's say. You set the month 30, and then you set it to 2. So there's no 30 basically. So basically if it's over 28, they will just set back to 28. You just make it default. Now this one is extra, program music player. Basically what we put in music.c, we play it back here. Very simple stuff. Okay, this one is the main alarm program, so-called main alarm program. When alarm is 1, you play the music of choice until you press the center button. Then you set the alarm to 0, and then it breaks the while loop, and then you go back to the main program. So this is to initialize switch and such. Now onto the board itself. This is a demonstration. So basically we have a pre-programmed date. Then let's say we set the date to be, let's say 2018 12/20. So we set it, then we go back, so it displays correctly what we wanted. Now for time, so now it is 9:02. Basically we want to set it to, let's say 10 o'clock. We set the time, then we set the hour to 10, and then minute we don't change it. Then we set, maybe I'll change it for this demonstration, because why not. So set it. Now go back, and boom, it's 10:05. The second is not affected though. Now for the alarm, let's say we want the alarm to ring at 07. Wait, okay, let's say we want it to ring at 07. So set time 10. Wait, no, back. Set alarm. So 10:07. 07 here. So we set it. Okay. Now I press back, and then we wait. Hope you don't mind. We're gonna wait.
Yeah, explain
其他东西我觉得没有什么好 explain. So while I did, I'll show you some cool stuff hopefully. Oh yeah, so for our music stuff, I'm not a musician by talent or anything. So basically, what we have here, oh right, we have to explain how we get the music to run. So wait, it's already 40 seconds. I'll do it later. 26, 47. 1, 2, 3, 5, 6, 7, 8, 9. So it's ringing basically. Okay, so we cancel it by pressing the center button. Now, the cool stuff is we define first for the music. We define all the notes, and basically we have also the B flat, which is A sharp basically. We just define everything we know about music. These are the frequencies. Later it will be explained how we find these frequencies. And these are all because header files are you can parse the functions between other C files if you include the H file. Now, music, basically we have the play note function, the note which is already defined in music.h, and also the tempo. So these are the ones here. Plus. For every note play, we'll put something like a button here. So when we press it, right, you cancel the music and then you return. This is what's driving the alarm system also. But we also have a cool feature in the main program where we play music. Alright. Now, for the FTM, so we're using port A4. Since it's the easiest, basically we have FTM0, FTM1. Now we use SIM SCGC5 to switch it on, then port max 3, the configuration. Now we have FTM, which we are using SIM SCGC6. SCGC6 will be following the RTC most likely, since it's that way, we configure it that way. And these are the basic ones. So these are the interrupt enablers. We don't put it as separate because we're gonna call it when we initialize it anyways. So NVIC enable IRQ. This function enables the interrupt request for INT FT0, which is defined in another header file. This is the handler for two of it. Okay. And then we have for play note. So basically we call in the note, we call in the tempo, then we assign it to their respective internal what do you call it, variables. So if the note is stopped, we want nothing to happen, so we set the clock to 0. So what happens if we set the clock to 1? Basically you'll play a noise because of the clocks. Basically you play noise, so it goes like tut. So we kind of disable it because we don't want any sound. We allow MT1, which controls the tempo, and then for else, which is when it's not stopped, we want it enabled, so we can pass the frequency into it. And then after the note is played, while the tempo is 0, tempo must not be 0, we stop it. Okay, now when the alarm trigger, you can cancel it. Additional features, additional features.
Okay.
So one additional feature we have is music. So we have 3. All of them can be cancelled. So for the second one, okay, so these are the few. One thing I noticed is when you play a music, it kind of like follows the clock for the RTC, I think. So that's all. I'm gonna pass it to.
Now I will explain answer the number 6. Answer the following questions. The controller is basically what is the controller doing most of the time is basically just stay on the menu until something is pressed. And then now I will explain these 3 questions together. Now, okay, I will just show you the calculation part first. Okay, first the prescale is set to 4. You can set to 8 if you want. And then the clock frequency we use is 48 megahertz. As for to calculate the FTM clocks, we use the clock frequency divided by the 2 to the power of 4, the prescale. So let's say if you use other pre-serial value, you can change the value here. And then to calculate the tick required, we use half period over FTM clock. And since we don't have the period yet, so the period can be obtained by 1 over frequency. As we know that the clock frequency is 48 MHz, so the calculation and final answer is this 2.083. And then we will divide it by 2 to get half period. And then after we get a half period, we will put inside this formula so that we can obtain the tick requirement. As this table is to show that every node A6, B6, C6 and so on, the value of frequency, period, half period and tick requires is shown in this table. So that's all I think for answering the following questions. Thank you.